Okay, these are some solutions for the practice test for Chapter 5. And the first one, we're going to use the table. Shows the velocity of a car in an amusement park ride. During the first 24 seconds of the ride, use the left endpoint values, LRAM, to estimate the distance traveled, using 6 intervals of length 4. So we're going to use LRAM, so we're going to use the left endpoints here. These would be our intervals, time 4, 8, 12, 16, 20, and 24. So those are our intervals, and these are our endpoints. So these are the lengths. And you could just kind of draw, you don't have to kind of, you can plot all these if you would like. But you could just call this as going to be 0, and then 4, 8, 12, 16, 20, and 24. So if you're going to use the left endpoint, you're going to use this point for the left endpoint of a rectangle. So this would be 0, and then this would be your height here, excuse me. And then the velocity here is 2, so it might be up here to 2. So, and then the next velocity would be 5, something like that. So these are going to give you your altitudes or your heights of the rectangles, and we're going to use 6 intervals. So 1, 2, 3, 4, 5, 6. So these will be my 6 left endpoints. And my base is going to be 4 for all these rectangles. So that's all you would have to do, calculate it. You could kind of do it intuitively. So here was the data that I did just for this one problem. So if you look at your table, this is my first left endpoint now. So that's going to be the height of my first rectangle. This is my second, third, fourth, fifth, and sixth. So we're using just the left endpoints. And the base of all those rectangles will be 4, so it's just 4 times. If I add these up, 2 plus 8 is 10. 13 plus 17 is 30, so 30 plus 10 is 40, plus 5 is 45. 4 times 45 is 180. So I got 180 feet. Now you could draw a sketch and you could put these in if you wanted to see those, but that's all you really have to do is draw just a number line like this. And you know that you're going to use those left endpoints, so those altitudes will be given by this. So this would be 0, 2, 5, 8, 13, and 17. Now if I was going to use an RRAM, then I would be using these 2, 5, 8, 13, 17, and 23. And that would be probably an overestimate of my area. Which would give me my total distance traveled. All right? And number 2, for the curve, y equals negative 5x squared plus 8, partition this into 4 subintervals, negative 4 into 4 subintervals using MRAM. So we're going to find the midpoint for those 4 subintervals to approximate the area. So that's pretty good. If I've got from negative 4 to 4, my distance is going to be 8. And I'm going to use 4 subintervals, so each of those will be 2. So this will be 1 subinterval, negative 4 to 2. I drew a little sketch here. Now it was easy to sketch this parabola because it's shaped like an N. All right, and it's going to be a little bit wider than normal parabola because there's a 0.5 coefficient. And if I want to find out where the zeros are, I can just say 1/2 x squared plus 8 equals 0. Subtract 8, multiply by 2, multiply negative 2, and I get x squared equals 16, so x equals plus or minus 4. So my zeros are plus or minus 4. And when x is 0, my intercept is 8. It's symmetrical, so it looks like this. And actually, you could just find the area of these 2 rectangles and double it. But I went ahead and did all 4. It's real easy. And we're going to do 4 subintervals, so each one's going to be 2 units, which is nice because that makes it easy to find the midpoint. So these are my 4 intervals. Now remember, the base of each of these will be 2 units. And I just have to find the height, and the height is going to be determined by the value of the function at the midpoint. So I'm going to take f of negative 3, f of negative 1, f of 1, and f of 3, and those will give me the heights of my midpoints. And that's going to be what the rectangles are going to look like. And again, you can see that these are the same and those are the same, so we could just double it. So we should get a symmetry. So what I did was I just took f of negative 1, and f of negative 1 was 15 halves. And then I took f of negative 3, And I just put this in my function, so negative 3 squared is 9, that's negative 9 halves, plus 8 is 7 halves. So I found both those values, and I realized this was symmetrical. So f of negative 3, 7 halves, f of negative 1 was 15 halves, and then f of 1, it's an even function, so if I negative 1 and positive 1 will give me the same result, so f of 1 was 15 halves, and f of 3 was 7 halves, so those are the same, those are the same. And if I add all those up, 15 and 15 is 30, plus 14 is 44, and divided by 2 is just going to be 22, and then I multiply by that 2, and they cancel, I get 44. So it was pretty easy. So it was set up very easy for you to just make sure you understand how to use the midpoints. And then, like I said, this is set up so the arithmetic is easy. So this should make sense to you. All right. And number 3, all we had to do in number 3 was we just had to express the limit as a definite integral. So this is my limit. And we know that these are going to represent any points in the function, so my function this will be the x. So this is going to be 7x squared plus 3. This will be a dx, and all this becomes the integral from 2 to 9. So basically it's just this. Translating that, integral from 2 to 9 of 7x squared plus 3x dx. So again, there's your dx. And this is going to be any point in our function, so this will actually be the altitude, or the height of my rectangles when I add them all up. As I take these limits, using these Riemann sums, and again, this will be 7x squared plus 3x gives me my function. Okay, so I hope that's pretty straightforward.